Okay, so we've talked about degrees. I'm trying to remember exactly where we left off before break. We were looking at measuring angles. We talked about
acute, obtuse, right
okay.
angle, and talked about
Pythagorean theorem, similar angles, or similar triangles.
the different sides.
Yeah. Okay. Adding up all the triangle, adding up to 180 degrees and all that good stuff. Okay. Did we talk about how angles were measured, how there was the difference in direction and stuff like that, and then now it's the percentage of a fraction of a rotation? Don't think so? Okay, so that's where we need to be. Coming back after a week off, I am just as lost as you guys for the first few minutes of class. It all goes off of back when navigation was a more common skill. This is your compass rose. This would be the east, north, west, and south. East was defined to be 0 degrees. North would be 90 degrees. They keep going around. So this is 180 degrees, 270 degrees, and then 360 is back at 0. So if you're asked to adjust your course or to set a course in a certain direction, that's how it was done. If I have a ray, an array is just a point, you take a point and you move it in a single direction and go forever. The point starts at the center of that and goes in a direction. Let's say it goes like that. The direction of that ray is defined by this navigational system. So that might be 32 degrees is the direction of that ray. If I go back to that same starting point and I go in a different direction, maybe like that, I create a second ray. The direction of that ray, let's say that is 71 degrees. Well, those two rays that have a common starting point, that common starting point, which is called a vertex, at the origin of our graph, those two rays form an angle. And the size of that angle was originally defined to be the difference in direction. So here the difference, 71 minus 32 is 39 degrees. So this angle here is a 39-degree angle. Well, over time, fewer and fewer people use that skill of navigation compared to what they did years ago. So we have adjusted that a little bit. If you start in a single direction and you make a complete turn, how many degrees is that? 360 degrees. A complete turn is 360 degrees. If we start in a single direction and we turn back, so we're heading the opposite direction, how many degrees did you go? 180. How did you find 180? Half of 360. If we start in a single direction and we turn to make a square corner or a right angle, how many degrees is that? 90 degrees. How did we get that? Half of 180 or 1/4 of 360. So over time, what they have done is they've defined these angles to be a fraction of a full turn. 90 degrees, 90 over 360 is 1/4. That's a quarter of a full circle, or a quarter of a full turn. And that's what the newer definition of an angle is the fraction of a full turn, where a full turn is 360 degrees. Well, what if we need to measure angles that are a little bit more precise than a degree? For example, we might need an angle measured at 28.65 degrees. That's where we're heading with it, yep. This notation is what we call decimal degrees. The abbreviation for that is going to be DD. But just like we have feet, and then we got smaller units, inches, or we've got, cups, and we've got smaller units of fluid, ounces, and so on. there are smaller units of measure for angles than a degree. 1 degree contains 60 minutes. The notation for that, 1 degree, of course, is the little circle. For minutes, it is a single quote. So you have to be careful. That's the same symbol for foot. Now, obviously, not too many things are going to measure out as 60 feet, but it can get confusing sometimes. If we want to go smaller than a minute, 1 minute contains, and this one kind of makes sense, 60 seconds. So again, 1 minute is the one with the single quote. Seconds is a double quote, which is the same symbols for inches. So you can see how it can get confusing with feet and inches sometimes. Generally, your seconds are going to be more than 12. So you would never have more than 12 inches listed with feet. So that's usually what helps you avoid confusion, is seeing that and knowing that it has to be seconds and not inches. But like I said, be careful with them. Know your context. So the first thing we're going to look at is we're going to convert. If we have an angle that is listed as 32 degrees, 15 minutes, 48 seconds. That is what we call degrees, minutes, and seconds notation. Abbreviated DMS for degrees, minutes, seconds. So if I want to convert 32.65 degrees, that's in decimal degrees, and I want to convert it to degrees, minutes, and seconds. The 32, the whole number, stays degrees. It is the 0.65 that's going to get converted. We're going to convert that by multiplying by 60 minutes in 1 degree. So here the degrees would cancel out. 0.65 times 60 is going to be 39. Degrees, minutes, seconds. So here that's just 32 degrees, 39 minutes from the 32.65 degrees. If I'm doing this on my calculator, I would simply do this, 32.65. That's in degrees. I would subtract off the whole degrees, which is the 32. 0.65, I'm going to multiply by 60. 39 minutes. Well, what if I have something a little bit more complicated? It's not going to be in whole minutes. What if I have to go down to the seconds? Well, I might have 18.1875 degrees, and I want to convert that to degrees, minutes, and seconds again. Well, I'm just going to go ahead and start out in the calculator with this. Now I'm going to take a little shortcut, however. I know this is going to be 18 degrees, so I don't really need to enter the 18 degrees. All I need to enter is the 0.1875 degrees. So that's what's left over after I take off the whole 18 degrees. What am I going to do to the 0.1875 to convert it into minutes? Times 60, which is 11.25. So that tells me it's 11 minutes. I'm going to subtract off the 11 minutes. I've got 0.25 minutes. How am I going to convert that into seconds? Times 60 again. 15 seconds. So that's 18 degrees. The whole degrees didn't change. 11 minutes, 15 seconds. So let's say we have 47.5625 degrees. Tell me where to start. 47 is just going to stay degrees. Onto the 0.5625. What am I going to do with that? Times 60 will make it 33.75. So I'm going to keep the 33 minutes. Then what? Subtract the 33. And then times 60 again to make it seconds. 45 seconds. So 47 degrees, 33 minutes, 45 seconds.
Can you bring your calculator back up?
Sure. I think it still smells over there. Gee. Now, depending on what you have for calculators, I see you guys have 3 different versions, but I think I know how to work it on all of them. On the graphing calculator, yours is the exact same as mine. If you were to enter 47.5625, hit equals, you've got an angle menu right up here. You got to hit the second key and then angle. And your fourth option is DMS. Arrow down to 4 or just select 4. And it'll come up like this. You got to hit enter twice. You got to hit enter again. And there it is. 47 degrees, 33 minutes, 45 seconds, which is what we had. On yours, you're going to do the same thing. You're going to enter 47.5625. So 47.5625. You've got a key up there that should look like this.
Yeah.
Hit that key, and you'll see the degrees, minutes, seconds symbols. Use your right arrow off the right side of the screen.
DMS.
And select DMS, and again, you'll have to hit enter twice. Andrew, do you know how your calculator works for that?
No, but I got it.
You've got her? Okay, so otherwise I have to come take a look at yours.
Yeah, no, the only reason I know about this calculator is because we kind of briefly brushed over this.
Okay.
So my teacher taught us how to use start using our calculators.
Oh, perfect.
Yeah.
Because, yeah, that calculator actually converts to polar and everything. We're not going to get into polar coordinates in here. So, anyway, I'm going to have you guys convert for me then. 28.638 degrees. Convert it into DMS. Yeah, you get 28 degrees, 38 minutes, and 16.8 seconds. Generally, when seconds, you would never go past 1 decimal place in the seconds. Some calculators will go 3 or 4 decimal places. It's really not practical. In practical application, I've seen very few applications, and I've done some work in precision tool making, stuff like that, where they have to be very precise. I've never seen, very, very seldom do I see an angle that's measured below 10 minutes. So it's a 1/6 of a degree. To measure anything more precise than that, you have to use what's called an optical comparator, which is it's a light, but it's got a very specific magnification. So you set the part on that light, then it projects it up onto a screen where you can see all the little details are magnified, and you can measure it a little bit more precisely there. But even then, measuring angles down smaller than a minute requires laser measurements. And most companies don't need that precision where they would spend that money on a measuring device. I mean, I've never, ever seen anything measured below 1 minute in practical application. So the seconds are kind of,
Is there ever gonna be a thing where they're gonna do that, or just?
you know, the only place I could ever see it is if you hear about nanotechnology all the time, and a nanometer is just a billionth of a meter, which is around the size of an atom. Between 1 and 10 nanometers is the size of an atom. So the only way I can see needing angles more precise than that is if they actually do start to get deeper into that nanotechnology and nanoscience and start building things on that level. Then those angles become more relevant. But you're building things that are so tiny, that so far away from what we can actually see, that it would be computers and such doing those assemblies. That's the only thing I can possibly see. And possibly like in the medical side of it. Again, it would be nanotechnology that would be able to achieve it. But, they talk about possibly being able to send tiny little robots into your body to do repairs instead of where they can just inject it in with a needle and then call it back out or whatever, rather than having to cut you open. That's all a dream at this point, but hopefully. How about going the other direction now? We're going to go DMS back to decimal degrees. So if I have 43 degrees, 18 minutes, 36 seconds. Now I want to convert that into decimal degrees. Well, we start at the end. On the last one, going from decimal degrees to DMS, we started with the whole degrees and we move down. Here we start with the seconds. And we're going to convert seconds into minutes by dividing by 60. So on my calculator, I start with the 36 divided by 60 gives me 0.6. I'm going to combine that with my 18 minutes. So on my calculator, I just add the 18, add the minutes. And then I'm going to convert that into degrees by dividing by 60 again. So I've got my 18.6, I divide by 60 again. 0.31, and I add my 43 degrees to that. So that's 43.31 degrees is what we're getting there. So let's say I have 19 degrees, 54 minutes, 27 seconds. On my calculator, I will start out with the 27. What will I do? Divide by 60 to convert that 27 seconds into minutes. So that is 0.45 minutes. So now what do? Add the 54 minutes to my 0.245 minutes. So I have 54.45 minutes. Then what? Divide by 60 one more time, turn those into degrees. 0.9075 degrees. I add my 19 degrees to that. 19.9075 degrees. Now, to do this on the calculator, you have to enter the degrees, minutes, and seconds. Hunter, yours is probably the easiest calculator to enter that in. If I wanted to enter 19 degrees, 54 minutes, 27 seconds, you enter the 19. You press that key with the degrees, minute, second symbols, this one here. Select the degrees, hit enter. Then you type in the 54, press that key and arrow over to the minute symbol, and hit enter. Then type in the 27, press that key, and arrow over the second symbol, and hit enter. Now just hit equals. It'll automatically change it to decimal degrees. Should. Yep. On yours, the thing is, where's the second symbol, right? Yeah. So on these calculators, for the sake of efficiency, they use the second symbol. They have it down here because they use the double quotes for a lot of other things. So yeah, it's 19. You do second angle degrees, 54 second angle minutes, and then 27 alpha seconds. Then you hit equals and it automatically converts it. So we can convert back and forth. Our next step is to do operations. And we started off the semester reviewing operations with, feet and inches and stuff like that. It's the same type of concept here. We just have to remember that our conversion factors are 60s instead of 10s or 12s or whatever. So if we have 19 degrees, 42 minutes, 38 seconds, and I want to add 35 degrees, 23 minutes, 47 seconds to that. As always, I start on the right and I work my way back to the left. 38 and 47 is 85 seconds. Now, of course, 85 seconds is bigger than a minute. I can take out 1 full minute, and how many seconds would be left over? 25. Good. 1 minute is 60 seconds. So I take 60 out of 85, I'm left with 25 seconds. So what I'm going to do here is I'm going to keep the 25 seconds. And I'm going to carry the 1 minute over into the minutes. Now I have the 1 and the 42 is 43. Plus 23 is 66 minutes. Now, once again, that is more than a degree. I can get 60 out of there once. That's 1 degree. With how many minutes left over? 6. So once again, I'm going to keep part of it. I'm going to keep the 6 minutes. And I will carry the 1 degree. Well, 1 and 19 is 20. 20 plus 35 is 55. 55 degrees. I'm going to have you guys try one. 21 degrees, 39 minutes, 17 seconds, plus 8 degrees, 43 minutes, 52 seconds. So 17 plus 52 is 69, which is 1 minute and 9 seconds. So I keep the 9 seconds, I carry the 1 minute. 1 and 39 is 40, plus 43 is 83. That's 1 degree, 23 minutes left over. 1 and 21 is 22, plus 8 is 30, so that's 30 degrees, 23 minutes and 9 seconds. Does that work? Now you can do that on the calculator too. You just have to punch it in. It takes a while to get it punched in, but it should spit it out. It may, when you get your answer, spit it out in decimal degrees. You just got to go back in and do 2DMS to change it back to degrees, minutes, seconds.
I'm curious, you know what the R and G stands for on this calculator?
Yeah, that's for polar notation.
Okay.
And yeah, we're not gonna get into that in this class. You mean RNG or RND?
No, it just says R and then separate symbol as G.
Oh, gotcha. R would be radians,
Okay.
and we'll talk about those actually in later this week. G is gradients. Gradients is the attempt to make a metric unit of angle measure. A gradient is 100 gradients makes a complete circle. It's kind of an interesting thing between 360 degrees makes a complete circle, 60 minutes in an hour, 60 seconds in a minute, and all that. Ancient people were fascinated. I believe it was ancient Egyptians is where the angles and stuff in time came from. Were fascinated by the number 360. The reason was it could be divided by 2, it could be divided by 3, it could be divided by 4, 5, 6, not 7, but 8 and 9 and 10, 12, 15. I mean, it could be divided by a lot of numbers. I mean, there were very few numbers that couldn't divide into it. And so 360 was considered to be like one of the perfect numbers. And so that's why 360 occurs and the 60 occurs as a division of that, because it's 3,600 seconds in an hour. It's that number occurs over and over again, the 60 and the 360, because of that. Okay, let's look at subtraction. What's that? So let's take 28 degrees, 42 minutes, 14 seconds, minus 7 degrees, 43 minutes, 51 seconds. So we go to subtract here. We have to borrow. So this is going to be 41. What's this going to become? 74. Because we borrowed 60 seconds from when we borrowed that 1 minute. So 74 minus 51 is 23. 41 minus 43, we're going to have to borrow again there. So this will become 27. This is going to become 101, because we borrowed 60 again. 101 minus 43 is 58. 27 minus 7 is 20. 20 degrees, 58 minutes, 23 seconds. Now, have you guys try one? 42 degrees, 19 minutes, 37 seconds, minus 18 degrees, 48 minutes, 41 seconds. Okay, so 37 minus 41, what are we going to have to do there? Borrow. So this becomes 18, and this is going to be 97. 97 minus 41 will be 56. 18 minus 48, of course, doesn't work. We borrow, this will become 41, and this will become 78. 78 minus 48 is 30 minutes. 41 minus 18, 23 degrees. So 23 degrees, 30 minutes, 56 seconds. Any questions? Multiplication's a little trickier. Let's say we have something like this and we're going to multiply it by 6. We need 6 of them. We start out with 35 times 6, which is 210 seconds. How many minutes can we get out of there? How many times does 60 go into 210? 3 times. 3 times 60 would be 180. 210 minus 180, that means there's 30 left over. Think of it as a division and a remainder. This is the number of whole minutes. The remainder is the number of seconds that are left over. So we keep the 30 seconds, and we're going to carry the 3 minutes. Now, this is where a lot of people make a mistake. We have to multiply first. Those 3 minutes we carried are going to come into play after we multiply. 6 times 27 is 162, right? Let me double check since I'm a little off today. Yeah, 162. Plus the 3 is 165. So now we've got to do the same thing. Divided by 60. 60 goes in there twice. That's 120 with 45 left over. So 2 is what gets carried into the whole degrees. The 45 stays in the minutes. And now we have 6 times 18, which is 108, plus the 2 is 110 degrees. So really the toughest part there is dealing with the carrying and figuring out what's left over and all that. How about if we want to divide? 47 degrees, 38 minutes, 24 seconds. Now I divide it into 8 equal pieces. 8 goes into 47 how many times? 5 times. Right? 5 times 8 is 40 degrees. So now we have to subtract 47 degrees minus 40 degrees. There's 7 degrees left over. Next, I would bring down the next unit, but before I bring down my 38 minutes, I have to change my 7 degrees into minutes. So that's 7 times 60. That's 420 minutes. I'm going to add the 38 plus the 420 is 458 minutes. 458 divided by 8. It's 57. If I punch it in the calculator, 458 divided by 8 is going to be 57 point something. 57.25. So it's 57. So I do 57 times 8. It's going to give me 456. I subtract, that's 2 minutes left over. What do I have to do that 2 minutes before I can bring down my 24 seconds? Convert it. 2 minutes is how many seconds? 120. 2 times 60 is 120. Bring down that 24 there. Plus 120 is 144. $144 divided by 8 is 18 seconds. What do you think? That one might take a while to get used to. That one might be where the calculator comes in handy. Okay, how about this? Find the complement of 27 degrees, 18 minutes, 51 seconds. Complement means they add up to 90. So we have to subtract from 90 degrees. We have to fill in zeros there. A lot of places would fill in double zeros just to fill up the digits. We can't do 0 minus 51, so we got to borrow. Nothing here to borrow from, so we go to here. This becomes 89 degrees. That would make this 60 minutes. I need to get it down here, so I'm going to borrow there. That's 59 minutes. This becomes 60 seconds. Now I can subtract. 60 minus 51, 9 seconds. 59 minus 18, 41 minutes. And 89 minus 27, 62 degrees. Find the supplement of 113 degrees, 51 minutes, 7 seconds. Supplement means we have to subtract it from 180. I'll give myself room to do this here. So again, I can't do 0 minus 7, so I'm going to have to borrow. Nothing to borrow from here, so I go all the way here. This becomes 179. This would be 60. Well, I need to get to here, so I got to borrow again. This is going to become 59, and this is going to be 60. What's next? 60 minus 7 is 53 seconds. 59 minus 51, 8 minutes. Again, depending on the notation, some people leave it as just 8, some would put it as 08. If you're entering in the calculator, you usually have to put in the 08 a lot of times. And then for degrees, 179 minus 13 is 66 degrees. What do you think? Still better than a sharp stick in the eye? Yep. 110, 45, 30. Did you get the 30 part?
Yeah.
How about the 45?
No.
Okay, so you carried the 3, right?
Yeah.
Then you had to do 6 times 27 first.
Yeah, I can do that.
You added the 3 first?
Yeah.
That's the problem. That's usually the biggest mistake people make on those, is they add the 3 before they multiply. Remember, order of operations says you multiply before you add. In the big packet that I gave you the week before spring break, on page 461, it's exercise 20-4, the odds. Page 464 through 465, exercise 20-5A, again the odds. Page 467 through 468, Exercise 20-5B. And page 472. Exercise 20-7.
Gonna carry us in next week then with all this?
This homework? Well, you guys get tomorrow off because you're going to a conference. So
And
I had to cover a little extra today.
then
Then
we're gonna have a sub on Thursday then?
there won't be a sub on Thursday. No,
Class Thursday,
just no class Thursday.